This is an interesting question because of the negative signs. Okay, so I want you to think about this for a second. The car starts from rest. It starts from rest and it travels for 5 seconds with a constant acceleration of negative 1.5 meters per second. So if it starts from rest and it changes its velocity by negative 1.5 meters per second every second, it's getting faster. Like the number itself, if you just look at the number itself, that's going up, but in the negative direction. Remember that specifically, the negative is for direction, and this part of it is for speed. So what this is sort of telling me is that if the way I drew my picture and I'm getting the car moving towards the right hand side of the page, I'm actually calling that the negative direction, and this is positive. You could have drawn this completely differently. You could have had your car going this way, and that could be the negative direction in this example. This would be negative, positive. But you don't have to necessarily do that. We can treat the direction it's traveling as negative. So that means when we say the acceleration is in this direction, the acceleration is negative also. So in this example, the velocity, let me write that in a different color. The velocity is negative, and the acceleration is negative. I know the velocity is negative because it's moving in this direction. It's moving in this direction. I know the acceleration is negative because they tell me. So this brings me to an important point. When the velocity and the acceleration have the same sign, they're both negative. Sign. This is supposed to say sign. That means it's speeding up. So even though the acceleration is negative, it's getting faster and faster. Because think about it, if it starts off at, so they tell us it starts off at 0 at rest, and then it's accelerating at negative 1.5 meters per second squared for 5 seconds. So the time is 5 seconds. And it's asking what's the final velocity of the car. So the final velocity is my question mark. The X is my don't know, don't care. So let's try to figure this out. We're going to put in, so since X is my don't know, don't care, the equation I'm going to use is VF equals VI plus A delta T. And since it's already solved for VF, I'm just going to plug whatever in. So that's 0 plus negative 1.5 times 5. And that equals 1.5 times 5 is, what am I doing wrong here? V equals V naught. Because I'm not answering the right question. That's why. So the answer is negative 7.5 meters per second. That's how fast it's going. So because that negative, remember that negative means it's going in the backwards direction, or it's going in a negative direction. So this specifically refers to the direction. And the 7.5 refers to how fast it's going. So you can see if it started at 0 and it ended up at 7.5, it's getting faster and faster. But since it's moving in this negative direction, we know that it's getting faster and faster in the negative direction. So really try to keep track of the difference between the sign and the number. And it's important to keep track of those negative signs. They can kind of get you if you're not paying attention. Now the question says, how far does the car travel in this time? Again, what we can do is call this my question mark and call this my don't know, don't care. So this all was for part A. For part B, if VF is my don't know, don't care, then the equation I'm going to use is delta X equals V I delta T plus 1/2 A delta T squared. So we're trying to solve for delta x. So this becomes VI again is 0. This whole thing can go to 0 because VI is 0. So this equals 1/2 times A, which is negative 1.5 meters per second squared, times time, which is 5 squared. So delta x in this example is going to be negative 18.75 meters. And I will put that in a box, and I will put this in a box. Okay.